Hello, good day viewers. In our previous lesson, we have talked about the conjugate of a complex number, but in this tutorial, we will be evaluating powers of I. We have some problems here, but before we start, let us define I. You know, I is just the square root of -1, which we have seen in our introduction. So if I is defined as the square root of -1, this implies that I to the first power is just the square root of -1. So what of I to the second power? I to the second power. Square both sides here, you have I squared equal to just -1. So what about I to the third power? I to the third power is just the same thing as I to the second power multiplied by I, applying one of the laws of indices. But we have seen that I squared is -1, right? Then multiplied by I. This will give us what? Negative I. Therefore, I to the third power is just equal to negative I. Then what about I to the fourth power? I to the fourth power. I to the fourth power is the same thing as I to the second power multiplied by I to the second power, applying the same law of indices. I to the second power is -1. I to the second power is also -1. -1 times -1 will give us +1. So this is +1. Once you take I to the fifth power, it will start to repeat. So we're going to stop here. So these are the three important equations you need in order to evaluate powers of I. And we are going to be using them throughout. The first problem here is I to the seventh power. So we have I to the seventh power. How can we evaluate I to the seventh power? The last statement here is very much essential because we have seen that I to the fourth power is equal to 1 and all multiples of 4. So how many 4s can we get here? We can only get a single 4. So we are going to apply one of the laws of indices here to split the powers. So this is the same thing as I to the fourth power multiplied by I to the what? Third power. Because you know, in laws of indices, you can take one base and add the powers together. But we have already seen that I to the fourth power is 1 here. But what about I to the third power? Is equal to -I. So this is just 1 multiplied by -I, which is equal to -I. Therefore, I to the seventh power is -I. Then the B part. So how can we evaluate I to the 259? First of all, we want to determine how many 4s are available here, because we know I to the fourth power is equal to 1. So you can simply take your calculator, say 259 divided by 4, which I believe is equal to 64, with some remainder, but we are interested in the whole part. Then what of 64 multiplied by 4? This will give us 256, but this is what? 259. It implies that we have a remainder of 3. So we can write this as what? I to the 256. Then you multiply by I to the third power. Because if you add these two together, you're going to get 259. And this can now be simplified to -I, because we have seen that I to the third power is -I from here. And this one, since it is a multiple of 4, it will give us 1. So 1 times -I is still -I. Then the C part. I to the 910 is equal to I to the 908, then multiply by I to the second power. 908 is a multiple of 4. Therefore, the whole of this will be equal to 1. And I squared is just equal to -1, remember. Therefore, -1 multiplied by 1 is still -1. The whole of this is equal to -1. So this is what we have. We have I to the 846 plus I to the 29 plus I to the 7. We can express I to the 846 as I to the 844 times I to the second power. So this is I to the 844 multiplied by I to the second power. You know, if you apply one of the laws of indices, you'll be able to add these two powers together to get 846. Then the second one plus I to the 29 can be expressed as I to the 28 multiplied by I to the first power. So we have I to the 28, which is a multiple of 4, then multiplied by I to the first power, which is the same thing as I. Then plus the last one, I to the 7th is the same thing as I to the 4th, multiplied by I to the 3rd. So we know that all these ones will give us 1. We have I squared here, which is -1. So this is -1. Plus, we have I. But I to the 3rd power, remember, is negative I. From definition, you can see that here. It's negative I. So you bring negative I here. And I minus I is 0. So all we have is equal to -1. Let us take the E part. We have the whole of this multiplied by this. Let us simplify them separately. I to the 246 can be expressed as I to the 244 multiplied by I to the second power. So we have I to the 244, which is a multiple of 4, multiplied by I to the second power, then plus I to the 42. I to the 42 can be expressed as I to the 40 multiplied by I to the second. Then the other bracket. 32 itself is a multiple of 4, so we can write it as I to the 4th power raised to the power of 8, or we can multiply by 8 because 4 times 8 is 32. So it doesn't matter, once you have 1 here raised to the power of 8 will still give us 1. Then plus the other part, which is I to the 793. 792 is a multiple of 4, so we can write it as 792, then multiplied by I to the first power, which is the same thing as I. We have 1 here, we have 1 here, we have 1 here, we have 1 here. Okay, let's further simplify. We have 1 times I squared, and I squared is -1. So we have -1 plus, this is 1, I squared is -1. So we have -1 here, -1. The whole of this multiplied by, this is 1 plus, this is 1 times I. 1 times I is I. -1 is -2, so we have -2 here, multiplied by 1 plus I. 1 plus I. If you expand the bracket, you have -2 times 1 is -2, then minus 2I. So after simplifying the whole of this, we realize a complex number. Then F, which is second to last question, we have no problem with this because we know it is equal to 1. 8 is a multiple of 4. Yes, so we don't have problem with this one. We have 1 multiplied by the whole of this. 672 is a multiple of 4. So we have I to the 672, but still we have 3 left, right? So I to the 3rd power. But I to the 3rd power is -I. This is 1, this is 1. So the whole of this will give us -I. So this is -I. But I want you to try the last one. Try this one. Simplify this separately, then subtract whatever you obtain after simplifying this. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.